So now is probably a good time to start thinking about how we will get the note names of the different keys on our piano. First of all, we're going to put the names of the notes on the piano keys, but also when we want to highlight the notes later on, we will need to know what they're called, what the names are. So how can we do that? Let's go to the code. And what I'm looking for here is I would like to get all the natural notes within a range. So if I pass in, if we have a function and I pass in, let's say an array with two different strings, the first string will represent the first note that we want and the octave number. And the second one will represent the last one we want. So we want this function to create the natural note names between those two strings within that range. So an example I can show you here is, let's say that we want from F3 to A7, something like that. Then we will, just gonna comment this out. So then we will need to start at the F. We're not going to start at C, D, E, but then when we find F, we're going to start from there and from the third octave. So it'll look something like this. Maybe we'll have an array of arrays. So the first array will be the first octave, and that will be full of strings. So the first one will be F3, and the next one will be G3. And we're not going to worry about the black keys or the sharps and the flats yet. And A3, and the next one here will then be B3. So the next octave is going to be octave number 4. So that's going to start at C4 and it's going to go all the way up. I'm not going to type it in. Oops, create key. That's funny how it came up with that. But anyways, it's going to go all the way up to the last one, which will be B4. And then it's going to continue into the 5th octave because we're going all the way to the A7. We're starting at the F3 and then the A7, and then it's going to go keep going, keep going, keep going. And then the last one will be an array where we have C7 all the way up to A7, and then it's going to stop there. So that's what we're looking for right now. I want to have an array of arrays where every single array represents an octave, because this is the way that we're doing it right now. So let's think about how we can do that. And as I mentioned before, we also only want the natural notes to begin with, because we're going to take care of the sharps and the flats later. But we're going to need some information. So let's set up a variable with the actual natural names of the notes. And let's just call that natural notes. And that's going to be an array. And this array is going to contain all the names, all the string values of the natural notes, starting from C. So C with capital letters, and D is going to be the next one. And you guessed it, E, F, F, G, and the last one is B. Okay, good. So now we at least know the name of the natural note, and we have them in order here, starting from C, which is the first key in the octave, ending on B, which is the last key in the octave, before we go over this again and continue to the next octave. So this is pretty handy to have. I'm going to save that. And then let's, all the way down here, we're going to create a new method, and we're going to call that get all natural notes. Of course, in order to get all the natural notes, we need to know where to get them from. This is a spelling mistake, or that's a capital A. But we need to know in which range we want to get these. So let me up here, after we have the natural notes, I want to add a range. So we're just going to call that range. Let's store that range in an array of 2 strings. The first string being the name of the first note, and the second one, the last one we want on the piano. And in this case, it's an A7. We can switch these around later and see what happens. So now that we have our range here, we can go ahead and we can accept that into our get all natural notes. So to do that, I am going to do like this, like not curly brackets, square brackets like this, just like an array. And then the first one is going to be the first note, and the next one is going to be last note. So now we can use these as variable names inside of our function. So the first one will be F3 in this case, and the last one will be A7. And also down here, we need to take that first node and we have to figure out what is the letter, what is the node name. And then we also have to figure out what is the octave. So we have to split them up somehow. So let me just make a comment here and say assign octave number notes, octave number notes and positions to variables. And that's what we want to do. So the first one we're going to do, we want to have the first node name. So const first node name. And of course, that is going to be the first value of our first node. So that's going to be first node and 0, because that's the first value in that one. So in this case, first node name is F3. So 0 position in this one here, there'll be an F. And then we're going to need the last node name. Or actually, let's get the octave number while we're at it here. So let's get first octave number. And of course, similarly, it will be first node. I see I forgot a T here. And an S here instead of an A. And that's going to be the second position, which is 1. So now we have the first node name and the first octave number. The octave number, this is going to be a string. So because we're passing in a string, and if we're extracting this portion of the string, then it's just gonna give us a string down here. We don't want that because we want to use it for counting and calculations and stuff. So I am going to wrap this one in a parse int. So we're going to convert it to a number like this. So hopefully that should work. And the next thing we want to do is almost exactly the same thing, but we're just going to do it for the last node name. So I'm just going to take the last node name, just change the variable names, last node name and last octave number. And that should give us the values for this, A, which is going to be a string, and 7, which is going to be a number or an integer. Then we also want to find out the position, as I typed up here in the comment. We want to find out where does this the first node name, where does that start in this array? Where is that located in this array? So we want to get the position of F inside the array of natural nodes, and we can count 0, 1, 2, 3. So in this case, it will be F. We'll also need to get the position of A, so we need to know where to stop. So in this case, it's 0, 1, 2, 3, 4, 5. So let's try and find the position here. We're going to put that in constants as well. And first node position, we can call it that. And we want to take the natural nodes, the array of all the natural nodes, and we're just going to use an index of first node name. So that should give us, if it's present there, and it should be, then it will give us the position in that array. And we're going to do the same with the last node position. I'm going to copy this. And it's going to be last node position and last node name. Let's just try and console log this. So first node position and last node position. I'm just going to call it from here all nodes, and I'm going to pass in the range that we set all the way up here. Let's see what happens then. I save this, I go to the browser and get all natural nodes. First node is not defined. Okay. First node and last node. It's not being used, so that's last note, and of course last note here. Okay, that's what happens when you copy and paste too much. And I can see I get 3 and 5. And if we go and check that, let's see, we have, we just checked that before. So F is number 0, 1, 2, 3. So we get the position, and we get A will be 5. So 0, 1, 2, 3, 4, 5, which corresponds to A and here. So that works. That's good. So let's delete this console log. We don't need that anymore. Now we have to, let's create first of all an array to contain all of the arrays of the nodes of the octaves, if that makes any sense. It will in just a moment. So let's create a constant for this, and let's just call it all natural nodes. And that's just going to be an empty array like this. And then we want to make a loop here, because we want to start from the first octave number and continue to the last octave number. And we have those right here, last octave number and first octave number. So inside this for loop, we are going to set the octave number to be equal the first octave number. So this is just the iterator. We might as well just use I, but now that we know what we're dealing with, it's nice to name it correctly. So let octave number be initialized to the first octave number. Okay, that's the one we set up here. And as long as octave number is less than or equal to last octave number, then we want to increment the octave number. Okay, so what's happening here is that we're setting it to the first octave number, which in this case will be 3. And then so we're starting from 3. We're just starting from octave number 3 because that's where we want to start creating our piano keys. And then we're going to continue to the last octave number. As long as it's less than or equal to, in this case, 7, we want to keep doing something that we're going to put inside this loop in just a moment. Let me just make this smaller a little bit so you can see everything. So first we want to think about this. We have the first octave that we want to take care of first, and we know that we're not going to start on a C because we told it up here it should start on an F in the third octave. So we want to, first of all, we want to take care of the first octave. So let's just type a little comment here and type handle first octave so we know what's going on. So here we have to check, well, we know that the first and the last octaves can have less than 7 natural notes, but the ones in between, so in this case 4, 5, and 6, they need to have all 7 natural notes in there. So we only have to handle the first and the last octave, and we can put in a statement here and we can check if octave number, which is the one we're setting right here. So if that octave number is the first one, so if it is equals to the first octave number, we know it's the first octave. Then we want to do something here, and we just want to keep the last part of the natural notes array from the index of the first note position. I'm going to repeat that. We're going to keep the last part of the natural notes array from the index of the first note position. So the first note position, that in this case we have an F3, so that's 0, 1, 2, 3. So from here we want to keep this portion of the natural notes array, and we want to toss this out. We don't want to keep the CDE because we want to start here. Okay? A way we can do that is to just slice the array, make a copy of it. So let's make a constant called first octave. And this first octave will be all of the natural notes. And then I'm going to slice that. And when I slice something, I can pass in the first note position because that's where we want to slice it from, and we want to keep that one as well. So first note position, then we'll actually just get the rest of this. Let's just try and console log this so we can see what's going on. So console log first octave. Not first octave number, just first octave. Save that and go to our browser and see, okay, we're getting an array with the F, G, A, and B, and that's exactly what we want because we're starting from F, so we just want the rest of the array. So that's awesome. Now we have that thing. That is great, but in order to get, we want to put on the octave number as well, because right now, as you saw in the browser, we only have the node name. But the octave number as well, we can do that. We get an array from this, and then we can run another method, an array method called map, which will go over all of them and just add the octave number to it. So here I'm going to add map, and map will take a callback function, and we're going to pass in the node name. So that's for every single one of these. And then we're going to run this function here, and we're just going to add the octave number. So we're going to return the node name plus octave number. So the node name is every single one we got right here. So first it's going to be F, and then it's going to add the octave number, which in this case is 3. It's going to do that for every single one, and then it's going to return another array. Okay, let's check what happens. And as we expected, now we get the array, not only in the node names, we also get the octave, as we can see here. So that is great. And we want to take that array and we want to push it into our all natural nodes. So this is the first one, so we know that we're going to push the first octave into the all natural nodes array as the first one. So instead of console logging it here, let's just push it. Let's push it. All natural nodes, push, and we're going to push the first octave. Okay, not first octave number again, first octave. Okay, so down here we're still inside this if statement here. So what can we else do? Well, we need to take care of the last octave as well. So let's type out else if. So if octave number is equal to the last octave number, just like we have up here, if octave number is equal to the first, then we want to do something different. So octave number is equal to the last octave number. Then what are we going to do? Well, let's think about that. I'm just going to add another comment here so we can see what's going on. Handle last octave. And inside this, we are going to keep the first part and trash the last part of the natural nodes array. So in the first octave, we find, in this case, F, and we keep this part from F and all the way to the end of this array. But here we want to do the opposite. So we know that A is here, so we want to take this part, and then we want to trash the last part. We don't want to use that. Let's create, first of all, a last octave variable here. We're going to set that equal to, again, we want to slice the natural nodes array. Natural nodes, we're going to slice that. And we want to take it from the end. We want to remove the stuff from the end. So I'm going to pass in 0 first. And then I'm going to take the last node position plus 1. I'm going to show you in just a moment what that looks like. Plus 1. And that should be it for now. Then here I want to go ahead and I want to console log this last octave. And let's see what happens if we go to the browser. I get 7. That's not what I want, last octave. Not the last octave number, just the last octave. And then I get C, D, E, F, G, A, and that fits. So what we're doing here with the slice method is we're starting at the beginning of the array, and then we are continuing, including that one, and then we're going to the last position, last node position. And we're going to add one because we need to have that. Otherwise, if we don't add one, we can just try and do it here. Save this, go to the browser and see we only get all the way up to G, but we wanted to include that, so we need to add one to it. I hope that makes sense. Otherwise, you can go and check out the MDN docs on the slice method. So that's working right now, but also we want to add the octave number to this. So we're going to do something similar here. We're just going to take this array that this one returns. We're going to map that, and we're going to get another array. We're going to map it. We can just use the same thing here, and we're going to map it with the node name. And then we are going to just add return. We're just going to add the octave number. So return the node name plus the octave number. Okay. All right. So down here, instead of console logging the last octave, we're just going to push it to the array, to the all natural nodes array. So all natural nodes push. That's going to be the last octave, like this. Now let's see what we have here. We have node name. That's not defined. That makes sense because it's an O here. Let's check it out again. We don't have anything because we're not here. Just want to console log the all natural nodes. Let's keep that in there so we can check next time. So here we have two arrays, and the first one is the first octave, and here we have the last octave. So the first one goes from F3 to B3, which is great. And the next one, or the last one I mean, goes from C7 all the way to A7, but it leaves out the B7, which is great. But we need to put something in between here because we have a few octaves in between. But we know that they are going to be just normal octaves, and they're going to be exactly from C to B. We're not going to cut anything from the beginning or from the end of those octaves. So they're going to contain all of the natural nodes. So that's pretty easy to fix. Here we can add an else statement. So inside this else statement, we're going to just push the rest of the stuff in there, all the rest of the octaves that are in between the first and the last octave. And how we can do that is just by taking the all natural nodes. And we're going to push every single octave between the first and the last one in here. And we need all the natural nodes. So that's the natural nodes array I'm referring to. So natural nodes. And we're going to map that array to get an array from it. And we also want to add the octave number, just like we did before. So map here, I am going to add an arrow function like this. And then we can just return the node name, which I forgot to add up here. So I have to take this node name here, and we're gonna add the octave number to that. And that should be it. And then here, I'm just gonna take this one, the console log, and after this, all of these terrible statements here, if else, this, that, I'm going to console log the all natural nodes, and let's go back and see. Okay, we have, it looks right because the first array we have 4 values, and we have 6 in the last one, but every array in between we have 7, which corresponds nicely with 7 notes on a piano in an octave. So we have from F3 all the way to B3, and then we start at C4 all the way up to B4, C5 to B5, C6 to B6, and then the last octave, as we already know, is from C6 to A7. So now we have all the names of this, and instead of console logging this, of course, I want to return it. All natural nodes. So now we can use this method here to get all the natural nodes, and that's going to be pretty effective for getting the sharps and the flats as well. I think there's enough in this video for now, so let's pause here. Let's think about what we have learned and what we're actually doing here. And then in the next video, we will move on. And in the next video, I'm going to show you how I actually messed up a lot of stuff because I thought I wanted to do this in a specific way, but then I found out maybe there's an easier way to do it. So it's going to be a little bit tricky. We're going to delete some code. We're going to add some new code. But this is the first thing that I came up with, and we can probably still do it this way, but I'll explain in the next video my thought process behind those decisions that we're going to make. So please join me in the next video. See ya.